Section 6.1, Graphing Systems of Equations. Essential question. How do you solve a system of equations by graphing? Alright, so first we're just going to review a chart that tells us all of the possibilities for systems of equations. So, you can end up with parallel lines, intersecting lines, or identical lines when solving a system of equations. So identical lines make one line, intersecting lines intersect, and parallel lines are parallel. Excuse me. Parallel lines never touch one another, so they have no solutions. Intersecting lines intersect once, so they have one solution. Identical lines are always touching at all times because they make the same line, so they have infinitely many solutions. Identical lines have to have the same slope and the same y-intercept. Parallel lines have to have the same slope because parallel slopes stay the same, but they also have to have different y-intercepts because it's two different lines. Lines that intersect have to have different slopes. Alright, so graph the system of equations and explain your solution. So we have two equations here. Y equals negative 1/2 x plus 3 and y equals negative 1/2 x minus 2. So we're going to go ahead and graph both of those equations. So I'm going to graph the top one first. I'll do that one in red. So I'm going to put my first dot at 3 on the y-axis because that is my y-intercept. And then my slope is negative 1/2. So I'm going to rise negative 1, run 2. So down 1 over 2, down 1 over 2, down 1 over 2. And I'm going to make quite a few dots. We really want to extend our lines when dealing with systems. Alright, now I'm going to graph my other equation in blue. My y-intercept is negative 2, so I'll go to negative 2 on the y-axis, rise negative 1, run 2, rise negative 1, run 2, rise negative 1, run 2. And I'll extend that as well. So if you look at these two lines, they look like they might be parallel. Now before you say that they're parallel, I would always look at the slopes. Do they have the same slope? Yes, they do. So they have to be parallel. Sometimes lines will look like they're parallel, but they won't have the same slope. So they cannot be parallel if they don't have the same slope. Parallel lines have no solutions. So when the problem asks you to explain your solution, this is what they want. They want you to say that the lines are parallel and that you have no solutions. The lines never touch. Alright, second one. We have y equals x minus 1 and y equals negative x plus 5. So I'll do my top graph in green again. My y-intercept is negative 1. Now if you're confused about our slope, you can always put a 1 in front of any x that doesn't have a number in front of it, because that's what would go there. So our slope is 1, or 1 over 1. So rise 1, run 1. And we do that a bunch of times in both directions. So there's our first line. Our second line has a y-intercept of 5. And a slope of negative 1, or negative 1 over 1. So down 1 over 1, down 1 over 1. Alright, so you'll notice that these two lines cross, meaning that they intersect. So we're going to say intersecting. And since they intersect, that means they have to have one solution. And they intersect right here, which is the ordered pair 3, 2. if they intersect with one solution, you have to name the ordered pair. So that right there is how I got the 3, 2. You've got to include where they intersect. That is the one solution. So you need to name the solution. All right, now we have y equals negative 3x plus 5 and y equals negative 3x plus 5. Now, since we're graphing the same equation twice, really, you're graphing the same line. So the same line is identical, and identical lines have infinitely many solutions. You don't need to name the solutions because there's an infinite number of them. All right, y equals 1/2 x minus 2 and 3 over 2x minus 3. So I'll start with 3 again. My y-intercept is negative 2. Rise 1, run 2, rise 1, run 2. And then 3 over 2x minus 3. So go down to negative 3. I know that those look like they're, I'm going to scoot my line up a little bit because our y-intercepts are very close to each other. So rise 3, run 2, rise 3, run 2, rise 3, run 2. So these two intersect. Not at a very nice ordered pair though. So we'll still say intersecting one solution, and then we'll just have to do decimals for our coordinate point. So let's see, it looks like we're at about, actually that one doesn't look too bad. We'll say 1, negative 2 for where they intersect. Sorry,